So Unit 5 is our most recent unit going over exponential equation and logarithmic equation. So these probably will look a little bit more familiar to you as you go through it. I do have a few examples of each type, just really focusing on the things that we maybe needed more practice with from our test and to give us plenty of examples while we work on this from home in solidifying our understanding. The first type we had was when you had all of your exponential equations and you had the same base or similar bases that we could all put together. First off, what we needed to do was make sure that we only had one thing to a power on each side. So we combined together this multiplication that's on the left. And the way that you do it, when you multiply like bases, you add their exponents. So it's going to be 2 because the base doesn't change. And I'm going to add together 3x minus 2 and negative 2x to get x minus 2 for that exponent. What we said then, if you had 2 to a power equals 2 to a power, those powers had to be equal. So I'm going to do x minus 2 equals 3x and go ahead and solve that. With our exponential equations, you don't have to check anything. You, again, are always welcome to and to verify that the equation on both sides gives you the same answer, but you are not required to check. Going to the same type of problem, but a little trickier, was one that looked like this. Our first goal is to make this problem look like the one we just did by making all of the bases match. So you have to think about what you can rewrite all of these as. And all of these I can rewrite as 6 to a power. So first off, 1 over 6 is 6 to the negative first. 1 over 36, it's negative because it flipped, and it's a negative 2. So 6 to the negative second, and then this 36 is 6 squared. I'm going to do that multiplication, so negative x plus 2, this is negative 6 plus 6x, and this is 6 squared. And now this problem looks exactly like the one we did a minute ago. So what we need to do is combine these that are on the left. Since we're multiplying like bases, we're going to add our exponents. So negative x plus 6 is 5x. 2 minus 6 is negative 4 equals 6 squared. And then just like before, if the bases are the same, then the exponents have to be the same. So 5x minus 4 equals 2. And you get 5x equals 6 and x equals 6 over 5. Again, you don't have to check, but you are welcome to do that. Our second type was when your numbers were a little uglier and it didn't really seem like it was going to work out nice. And what we said to do was to start by isolating your thing to a power. So I'm going to start this by moving that 8 to the other side by subtracting it. Oopsies, 1.8. And then I'm going to divide everything by 9. And this gives me 5 to the 8 minus 10n equals 0.2. As it's written, we can't rewrite these to have common bases. There is actually a way to do it if you think about it long enough, but that's not typically what this is meant to do. So what we did is we rewrote it in log form, and we said, okay, log base, whatever your exponent is, so base 5, or your base of your exponent, of 0.2 equals 8 minus 10n. And then we could solve this from here. To get this number out of your calculator, remember that that's change of base. You're going to do log of 0.2 divided by log of 5. Oopsies, point. And that gives me negative 1, which is equal to 8 minus 10n. And then I'm going to solve it. Minus 8, I get negative 9. And divide by 10, and I get 9 over 10. Okay, talking about log equations then, we had a couple types of these as well, and there is an entire video notes of this day in class. What we said, if you have two logs, so if log of a number equals log of a number, then these numbers have to be the same. So those logs really just cancel, and you have 14r plus 2 equals r squared plus 50, and that's what we're going to have to solve. Anytime it is a quadratic and you have a squared term, set it equal to 0, and I keep that r squared positive, so I'm going to move everything over here. And then we have to try to multiply to 48 while adding to negative 14. Getting close. -8 and -6 will do it. Once you fully factor this, you should get r minus 8 times r minus 6, which tells you that r should be 8 and 6. But now that we switched to log equations, you have to check your answers. So we have to take these and plug them back in. And what you are specifically checking for, you cannot do log of 0 and you cannot do log of a negative. So you need to make sure that this 8, if you plug it in either spot, will keep it positive, which it will. And this 6, if you plug it in either spot, will keep it positive, which it will. So these work. So we can go ahead and try this one, which is a similar thing to what we just did, but it's going to require some condensing first, because I have these two logs on the left-hand side. Since they are added, the way we put them together is we multiply the insides of the log together, which you can write like that, or actually multiply it and write as x squared plus x. Either is fine by me. Then now this looks exactly like this problem that we started with a minute ago. So my logs cancel, and I'm just going to do x squared plus x equals 6. This is again a quadratic, so we need to set it equal to 0 and try to factor it. When you go through the whole factoring process and you solve, you should get x equals -3 and +2. But again, that's not the point at which you are done. If we take this 3 and go all the way to the original and plug it in, what you'll notice is that both logs actually become negative when it gets plugged in, so that answer won't work. However, if I take the 2 and do the same thing, both logs stay positive. This one's a 2, this one's a 3. So 2 is a totally valid answer, and it is in fact my only answer to this equation. This one's going to be our next type, though it starts out looking very similar to the one we just did, and we actually have to start it the same way of taking this left-hand side and condensing it together by multiplying the insides of the log together. But what you'll notice is before I had log equals log, and now it just equals a number. So I can't just get rid of this log for fun, because I can't get rid of the log on the other side. You have to be able to do it evenly. So what we do instead is we rewrite it in exponential form. It's always the base, so 9 to the other side of the problem, so it's squared, equals x squared plus 24. And then we're going to solve. 9 squared is really just 81. Oops. And then set it equal to 0, because again it's a quadratic. And we're going to try to factor this. Multiplying to -81 and adding to 24 is 27 and -3. And again, we're going to factor, and when you're done, it should look like this. And your answers are -27 and +3. But just like the one we just did, you can't just take those answers and run with it. If I check the -27, the minute I plug it in there, it would make that log negative, so I get to throw that one away. The 3, log base 9 of 3, that's fine. 3 plugging in there would be log base 9 of 3 plus 24 or 27, so that's fine. So x only equals 3, it does not equal -27. Okay. Last problem to do is going to be like that one, but I wanted to make sure we had one with subtraction to talk about how we condense that. Here you have 2 logs, and the way we put them together because they are subtracted is to do 9 divided by -x. When we do this, then, just like the last problem, you have log equals a number, so I need to rewrite it. So it's 6 to the first equals 9 over -x, which is really just 6, equals 9 over -x. And then I treat this as cross multiplying because there's a fraction involved, and you're going to get 9 equals -6x. And dividing by -6x, you get -9 over 6 equals x, which is the same as -3 over 2. What you do need to check still, if I plug this in here, will it work? If I plug it in, it'll be negative 3/2, which is positive, so it's totally fine.